Hey, I just want to do another quick video. I'm using prime numbers to get other prime numbers, and I'm going to make shapes of those prime numbers. And then another idea I came up with years back, using prime numbers to get other prime numbers, is that this is a different little addition game I thought of last night, and I just decided to put it on paper today. Later, I plan on using subtraction, multiplication, as you know, is repetitive addition, so I plan on using some subtraction, division maybe, or multiplication, and various things, square roots and whatnot, and just play with the idea, play with prime numbers, play with these prime numbers. So anyway, right now I'm just using addition, a little addition game. So I got 2, 3, 5. All right, 7, 11, 13, 17, 19, 23, 29, 31, 37. Okay, so a line there to separate. Let's see, we have 2 plus 5 equals 7. Right, and then we have A going to B, and that's 2, 5. And then A going to C, skip the 9 because 7 plus 9 ain't a prime number, that's not a prime number, so C, so that's 17 there. And then this one coming out goes to D, and that's here. 2 plus 11 is 13, so we had 17 plus 2 gives me 19, and 2 plus 11 gives me 13. All of these are primes. Oh yes, all of those are primes. So, and then I just connect imaginary lines. This is imaginary line, in this case representing the non-connecting of primes. And these real lines are the connected primes that adding primes together to get other primes, are the real lines. So that's that. So that's that shape. That seems a little harder. Of course, you can just use any string of numbers or row of numbers or grid of numbers, and using whole numbers or row numbers or whatever to get, and use the primes to add other primes to make shapes. Sure, but in this case we're just using primes. And so we have the next one is we have A, B, and C, just like you'd see any triangle. An isosceles triangle. I know it's not a right triangle, but anyway, A, B, and C, just like you would see a regular triangle, equilateral triangle. There we go. So we have 7, 3, 13, 7, 3, and 13. 13. So 7 plus 7 plus 3 equals 10 plus 13 gives me 23. Or 7 plus 3 plus 13 gives me 23, and 23 is a prime number. And then I did something crazy. I decided to add this going to that. And if you were to take, this is 2 here, 7 plus 2 is 9, plus 3 is 12, plus add the other 7, that would give you 19, and that's prime. But but that's not what I did the first time, because I wasn't sure if I would get primes with the others. And so I just went here, went to 5, and that's a 5 here. So I basically said 7 plus 2 plus 3 plus 5 gave me 17, and 17 is prime. And then going down here, if you connect 7 plus 11 and the 13 here, 13 here, you have, see, 11 plus 7 is 18, plus 13 is 31, so 11 plus 7 plus 13, I hope, is 31. Let's see, 18, 20 plus 13 is 33, minus 2, 31. Okay, 31. So what I basically did was added the 31 plus the 17, because I was left with this 5 here. So 31 plus 17 gave me 48. 48 plus 5 gives me 53. So that gave me 53 prime for that. So, and then to connect imaginary lines, the non-connecting primes, this goes here and looks like that. And you can connect another, make it like a diamond shape there. So that connects to that. So then I was thinking, what if you add these together, and then the 2, the 7, and the 3 gives you 10, and then do like another, and then 10. Both of these 10s add together gives you 13 plus 7 is 20, and then 10 plus 10 is 20, so that gives you 20. The 10, this is 10 and 10, but together it's 20, so this is 10. 10 plus 10 is 20, and basically, and then where's one of my cheat sheets? So I can't find it. That's nice. So, and then 20 plus 7 plus 7, so 20, because I just went ahead and said just the 3, added the 3 and the 5, I'm sorry, the 5 and 2, and just, went ahead and said these were 7, as if I'm doing like a squared plus b squared, a squared plus b squared equals c squared, or square root of the a squared plus b squared equals c, the hypotenuse thing. Anyway, so I have 7, 7, so we have 20 plus 14 plus 14 is 34, and then plus the 3 gives you 37, which is another prime number. So I don't know if people are following along with that exactly, but in the sake of time, just play with them on your own, play with the idea. So these prime numbers, and just kind of make a game out of it. So there it is. There's my next video of prime numbers and chicken scratch. My next video of prime numbers, and probably everything I'm going to say after that is blah plus blah plus blah. So I'll leave it there. Peace. Bye.